Children, listen. This is chapter number 5, continuity and differentiability, part number 5. Already 4 parts we have done. Now, fifth part, question number 19, we are going to continue in this. Show that the function defined by g of x is equal to. So, function is given g of x is equal to x minus greatest integer of x is given. So, is discontinuous at all integral points. So, what we have to show, which is discontinue. The given function is discontinue at all integral points. Integral points in the sense, ma integral na integer raja. Integral means what ma? Just integer. Another name of integer they will be telling integral. Understand? So, integral points in the sense, integer values. Okay, for all the integer values, this will be discontinue. That is, we have to say. And here, this greatest integer denote greatest integer or less than or equal to x. The meaning they are giving. Greatest integer of x in the sense, what is the meaning now? Greatest less than or equal to x. It should be less than or equal to x. Means inside if you are writing anything. Listen, Paraja. Greatest integer in the sense of what they are telling, less than or equal to x they are telling. It means 1.1 if you are writing na, listen, 1.1 if you are writing na, it should be integer. Our outcomes must be integer. That outcome must be less than or equal to inside what we have. Okay, inside x is there. So that inside x, suppose any decimal number na, it should be outcome must be integer, not should be integer. Not should be decimal value. Understand? Outcome must be integer. The integer must be either in plus or minus. That is not an issue, but it should be integer. Okay, and it should be less than or equal to. It can be equal to or less. It means 1.1 na. 1.1 less than integer is what? 1. Am I right? Suppose 1 itself I am giving na, equal to integer is what? 1. So whatever the number, 1.2 if you are giving 1, 1.9 if I am giving 1, because outcome must be integer and that must be less than or equal to, means whatever I am taking the number, it should be equal or less than that number integer. So 1.9 in the sense, less than this given number, what is the integer na? 1 only. Okay. Suppose if you are taking 2 in the sense, answer 2, because 2 is the integer, not issue. So 2.1 if you are giving na, what is that? 2 again. It's going on till 2.9 if I am giving na. So answer must be 2, like that. So whatever the number I am using inside the greatest integer bracket, it should be less than or equal to the given number. Okay, the less than or equal to must be what? Integer. If you are drawing the diagram, it will be coming like this. If you draw the points, that is 1, this is 2, here 1, here 2. If you are giving like this now, listen carefully. So like 0 also integer and 0.1 also 0, like that 0.9 if I give also 0. Understand? So that from 0 if I give 0, 0 is included, but 1 is not included, because 1 when I am giving it became 1, 1 when I am giving it became 1. So 1 is coming here. So 1.1 na, it will be again 1.1. Till 1.9 is my answer. But 2 when I am giving, 2 is jumping to here. 2, 2 it will be coming here. Like this it will be going on. Okay. Same manner the negative value also. So this is the greatest integer. We have seen 11th standard these things already. So here how we are going to do in a sum. This is diagram. So how we are going to do the sum, that we will see here. Right. So we have to prove that which is discontinuous. Discontinuity, that is we have to say. So in general nothing is mentioned. So in general means what you will take? C is any real number. Okay. So let x is equal to C be the any real number. Any real number. Any real number I am taking. So one function, one limit real number na, you can take directly function value and limit value. First of all, limit value x tends to C f of x, which is equal to, so that limit x tends to C, not f of x here, sorry, g of x. Okay, g of x. The g of x is what actually here? What is the g of x? X minus greatest integer of x. So this is the given function. For this, we have to apply the C. Okay. Listen, it's very simple. Listen, Raja. Suppose, listen, everybody listen. Suppose number 2 I'm taking now. 2 left side values, what it will be? 1.9, 1.8, 1.5 and 1, like this, like that it will be coming. So for all this number, if you take greatest integer, what is my answer? What is my answer? 1. What is my answer? 1. So that left, this is what? Left of 2. Left of 2. So left of 2, if you take a greatest integer, what I am getting? 1 number less. Listen carefully. 1.9 if I am taking greatest integer, 1. So 1.8 if I am taking greatest integer, 1. So 1.5 greatest integer if I take, 1 again. Okay, so 1 also it will be 1. So this is all actually what? Left of 2. So left of 2 generally, so that left side if you are taking any limit na, whatever number you are using, I used here 2. I used here 2. Okay, 2 left number if you take, what is that greatest integer, compared to 1 number less, I am getting answer. Okay, suppose instead of 2 if I am using C na, what is my answer then? C minus 1. What is my answer then? C minus 1. Have you understand? The same thing. So limit extends to C. Here suppose greatest integer just x I am giving na. The left side in the sense, what is my answer? C minus 1. Have you understand? Same manner right side. Right side if you are going na, 2 plus 1, sorry, 2.1, 2.5 till 2.9. This is what? Right. Right of 2. So right side here I have mentioned. Right side, whatever I am taking, the answer is what? Same number I am getting. It means 2.1 greatest integer what? 2. 2 also if you take greatest integer what? 2. So 2.9 if I am taking greatest integer what? 2. It means whatever the number I am using, the same outcome I am getting here. Have you noticed it? So that limit x tends to C plus if I am using for greatest integer na, I am getting as it is x inside what I have. Okay, no need to add, no need to subtract anything. It will be as it is will be coming. These 2 point, it means, so these 2 point very important in future for understanding the sum. So kindly write this also in a pencil. Okay, right. Now we'll enter here. So what is my answer? This is what? This is what? So we have to go then left and right. Left limit, then right limit we have to go. Okay. So left limit, right limit. So that this is then left hand limit, then minus, then minus. So what I'm getting then? Limit. Okay, now we can apply. So x will become what directly? Just C. Okay, just C minus greatest integer of what Raja? C will be coming, but left hand limit na, the C minus 1. Here we have what it will be? C minus 1. So normal bracket you just put. Don't use greatest, means this square bracket don't use. Square bracket only they are mentioning as an integer bracket, greatest integer bracket. Now multiple the negative inside. C minus and minus plus 1. Minus C plus C cancel na, plus 1 is my answer. This is my left hand limit answer. Okay. Then what about right hand limit? So that right hand limit if I am going, so that limit x tends to C plus g of x, which is equal to limit x tends to C plus, so here we have a x and greatest integer x. Now listen children, just here x in the sense, just x, instead of x we are replacing C minus, but what about greatest integer of right side of x Raja? Just C means just x means C we are substituting. Okay, just C will be coming, then C minus C what pa? 0. So that my RHL means right hand limit, which is equal to what, my dear? Right hand limit equal to what pa? 0. Right hand limit 0, left hand limit 1. Both are not equal, have you noticed? So left hand limit, right hand limit not equal. What you will say finally? Yeah, very good. Which is not a continuous. Not continuous means which is discontinuity. Okay. Hence given g of x, given g of x. So g of x is continuous at all integral point or all integers. Okay, all integral points are all integers, we can say. That's it. That's it, children. So these all points important. About integers na, you want to write this also, or only for this question I need the yellow color circle, you just write. That is also important for understanding. Sir, this is very important question, sir. Kindly put a mark. 2 mark question. Okay, 2 mark question important. They will be asking in a show that. Right, next question I'm going. I'll give time to write later. First we'll complete. Appa, listen. Question number 20. They gave question number 20. Is the function defined f of x is equal to x square minus sin x plus 5 continuous at pi? Question mark. They are asking to us, is that continuous at x equal to pi? So we have to check. So they gave x value also. They gave x value and one function. One function, one x value, na directly function value and limit value we have to see. So that limit value I'm going, limit extends to pi f of x, which is equal to limit extends to pi. What is the f of x we have? X square minus sin x plus 5. When you apply the what is the x value as a pi, what I'm getting then? Pi square minus sin pi plus 5. So that pi square, what is sin pi, children? Sin pi. Sin 180 what? That is sin pi. Sin pi means sin 180. Sin pi is what? 0. Sin 0, 0. Sin n pi. Sin n pi is equal to 0. Don't forget. Whatever the n, if you give negative, positive, n value 0. Whatever, if you give n, it will be 0. So that sin 1 pi is a 0. Okay. So that 0 plus 5, which is equal to pi square plus 5. This is limit value. Now function value means directly we have to substitute in the function as a pi. So if we substitute also same meaning only. So pi square minus sin pi plus 5, which is equal to again pi square 0 plus 5. That is pi square plus 5. Therefore limit value, limit extends to pi f of x and f of pi both are equal. Then given f of x is continuous at x is equal to pi. Okay, at x equal to pi, the given function is continuous. That is we have to talk. Okay, right, fine. Next, listen. Here they gave some specific function. Discuss the continuity. Discuss the continuity of the following function. Trigonometric functions they gave in addition, multiplication, subtraction, division only, not given. Right, fine. Before goes into this question, you want to learn what is that? What continuous of sin x, continuous of cos x. You should learn. Okay, shall we see that continuous of sin x and cos x? Right. So let's go to next page then. Let's see here. Suppose the question is given, prove that, or else check the continuity of sin x and cos x for any real number generally. Okay, so generally first sin x will go. Actually, if you are seeing example sums now, this is a separate question, cos is separate question they have given. Sin x first we will learn. That is also you should write in the class footnote. Okay, so that first sin. So any real number only we are going to check. This is question, answer I'll do in different color. So that let what is that? X is equal to c. Yeah, x is equal to c. Before that we will use what I am getting. Limit x tends to what we have to use, c. C is need then. Okay, let's go. Let what is that? X is equal to c be the any real number. Be the any real number. Right. If I'm taking now, so what I'm getting, limit x tends to c. Sorry, f of x. What is that? Limit x tends to c sin x. So that here just x can replace as a c, like that you should not do for trigonometry function. The C x is equal to something you have to assume here. Okay, so that let x is equal to C plus h will assume. H means some small changes, that is we have done in the example sum. I hope you people remember that. Suppose, listen carefully. Now this is I assumed. We knows that here x tends to C we know. X tends to C we know when we have a sign. Okay. Suppose x tends to C, if we apply here, what will happen? What will happen? You check. X tends to C if we apply now. As what I am getting, h tends to. Yes, very good. So see here you will be getting x replaced as C in the sense C is equal to C plus h you will be getting. Then C approaching 0. So that h tends to 0 you can write. See, in this x tends to C if you are applying now, it will be h approaching 0. So that then in the next step what I have to write, h approaching 0, it changed. After assume that limit changed. So that sign x what I assumed C plus h. What I assumed C plus h. Here it became a sin a plus b formula. So that sin of a plus b, which is equal to sin a into cos b, plus means plus only, cos a into sin b. So one more formula we have, suppose a minus b if you are using now, that is also we can go sin a cos b minus the minus, that's it. Cos a into sin b, that is the formula, but first formula I am using in this question. So that apply limit h tends to 0. What is that? Sin a means sin c into cos b means cos h plus cos c into sin h you will be getting. Now you apply the limit for both. H tends to 0 means sin c let it be into cos h na cos approaching 0. We know that you apply, and here cos c into sin h in the sense h value 0. Now what I am getting? Sin c let it be. What do you think about cos 0, children? Cos 0. Cos 0 1, sin 0 0. This trigonometric tables you must know. So cos 0 1, okay, plus cos c into sin 0 0. Have you understand? So that 1 into sin c I am getting, cos into 0 0. Therefore I am getting that sin c. This is actually what actually limit value x tends to c for f of x. This is what actually for a function value. Now sorry, limit value. Function value we should check now. Function value we should check, I'm right. Function value will check here itself. So that f of c directly we have to apply in the question. So that we have a function where actually our function is, let me write here somewhere else. Here I will write f of x is equal to sin x. Cos still I didn't do, okay, sin x. So that in the x I'm going to replace as a c, that's it. So that sin c you will be getting. Both limit value, function value equal now. What I want to say here, continuous I have to say. So that therefore limit value x tends to c f of x, which is equal to f of c, both are equal to sin c, then sin x function is continuous for all real number, or at c also you can write. C is the real number, now that is I am writing for all real number. So similarly you can go even for a cos. Similarly you can go even for a cos function also. Understand? Similarly I will be doing cos function. Listen, cos, next page I will go. Suppose cos, let f of x is equal to cos x I am taking. Same thing we have to do for a limit. Already I have assumed c is what real number. If you want to do, just write let x is equal to c be the any real. Be the any real number. Any real number. Now f of x which is equal to x tends to c, f of x is what? Cos x. So that here we are substituting, what is that? X is equal to c plus h. Same thing what I did in the previous, same thing I am doing. So that here we know that x approaching c, x approaching c we know, x approaching c now as h tends to 0 you will be getting. Okay, then you will be getting what, my dear? Then surely h tends to what, ma? 0 you will be getting. Understand that you can write. Now you just come here, so that limit x tend not x, now it became h. So h tends to 0, cos of x value what, ma? C plus h. The formula you must know, I'm right. Cos a plus b formula. Cos a plus b is equal to cos a cos b. Plus means minus here, opposite sign. Okay, so that sin a into sin b you will be getting. Suppose cos a minus b, if you have na, same formula, cos a cos b, but minus na, plus opposite sign I said. So that sin a and sin b you will be getting. First formula only I'm going to use in this. Okay, what is that? Limit x tends to 0, cos a plus b na, first cos c into cos h minus sin c into what is that? Sin h. So this is the function now. Apply the limit, children. H tends to 0 na, cos c into cos h value 0 minus sin c into sin h value 0. We know that I said now only cos 0 value 1 and sin 0 value 0. Okay, and since you write, now when you replace cos c, let it be cos 0 value 1 minus sin c, let it be sin 0 value 0. So that cos c into 1 cos c minus sin c into 0 0. So that what I am getting, cos c is my limit value. This is my x tends to c f of x. Now function value is what? Directly I want to apply c in the question. So what you will be getting, instead of x, it will become c. So both are equal now. Therefore, limit value x tends to c f of x and function value c both are equal to cos c. Then what we can say here? Then then cos x is continuous for all real number. For all real numbers, you can say. Understand? That's it. So by using with help of cos and sin, other trigonometry function easily we can say. Okay, that is what I have done. Cos and sin here. Now we can go to the question. So without knowing that cos and sin, you cannot come back here. That is what I have done. That too. Okay. So now 21 question we can go. The formula by using theorem number 1, I have given one formula. What formula na? F and G. Already in introduction I have given all those things. Okay, F and G are continuous at C. Then F plus G, F minus G, F into G, F divided by G are continuous at C. That is we can say. Here G not equal to 0, don't forget. Okay, so these things we know. So that one I am going to use now. So with the help of this sin, this proof and next page proof, very easily we can do the sin and cos. Sir, then in exam if they asked sin plus cos is a continuous na, surely you want to do next 2 pages. Next 2 pages you want to do in exam, then only you can do the A answer. Simply what I am doing now, if you do enough, they will not go, they will not give full mark. Okay. Now what I am going to do, A question, f of x is equal to sin x plus cos x. Okay. After done, the next 2 pages you want to do here. Okay. Now you just write f of x is equal to, you can write that this is g of x plus h of x. Understand? Where g of x is equal to sin x and h of x is equal to cos x. Okay, this is I have done. Now we know that sin and cos is what? Continuous at any real number. Am I right? So that you can write. So that we know that or else instead of writing we know that with above proof also you can write. Okay, we know that now you people using in exam. Okay, g of x is equal to sin x, comma h of x is equal to cos x are continuous at any any real number, bracket in right, proof given above. Above means the next 2 page only you want write, before you write 21, the 2 page you should write. That is what I am giving, proof given above. Okay, right, continuous now. Then we know that, or else that since we will use. Okay, then g of x plus h of x, x is, that means sin x plus cos x is also continuous at any real number. Any real number. Y means this one, this since you can use. Sir, this since you can use, sir. Okay, this since you can bring here. This since you can mention here. Okay. Let me given here. I gave the since portion here. Why the addition is continuous now? The since you can use. Understand? Right. So it's over. A is over. That's it. It continues at a real number. Like that B question. B is what? What is given? Subtraction. So that f of x is equal to sin x minus cos x, in the sense you take some name again. Similarly, addition is continuous now, even subtraction also continuous, even multiplication also continuous. Like that you have to give proof, but steps you have to show. Again it will be g of x minus h of x, where g of x is sin x and h of x is cos x. I am writing here itself, or continuous at any real number. Any real number. Okay, then you write that word. Then g of x minus h of x, which is equal to sin x minus cos x, is also continuous at any real number. Any real number. For this second one we can use. Okay, with help of the second result I am telling this. Like that third C1. C1 can you write the same manner, you people? Right. C1 also you can write. Or else I will do. C is what? F of x is equal to sin x into cos x. This we can write that g of x into h of x, where g of x is equal to sin x, comma h of x is equal to cos x, are continuous at x is equal to, at any real number. At any real number. Sir, the previous next 2 page proof, and this is very important. Okay, that is what we are going. Any real number na, then what is that? G of x into h of x is equal to sin x into cos x. Sin x into cos x is also continuous at any real number. Any continuous at any real number. Have you understand, children? Raja, see this, all the three proof with see, before you write this, what do you want to write? Next 2 pages, the sin proof, cos proof you must write. Next only you want to come 21st question. Understand? Right, very important. Next we are moving into, what is question number ma? 22 order, Raja, where we cropped 22. Yes, 22 question. What they are telling? This is continuity of the same two. That is what I am continuing here. So what they are saying? Discuss the continuity of cosine, cosecant, secant, cotangent. What about cosine? Cosine means what? Cos. Cos we have a given proof here. This one. Cosine only cos. Cos if you want to give, you give what is the 22 question number. Okay, 22 question here you give 22. 22 we are using. Okay, cosine means cos. Cos we have done already, leveled. Then cosecant, secant, cotangent. Tangent they didn't ask, cotangent they asking. Tangent also you can write if you want. Okay, so that cos already we have done. Cosecant will go directly. So that let f of x is equal to cosecant. Cosecant means cosecant x we can write shortly. For cosecant means cosecant x. Secant means secant x. Cotangent na cot x. Tan they didn't ask. Maybe they may ask in the example sums. They may ask in an example. Now cosecant x we are going. Cosecant how we can write ma? F of x is equal to 1 by sin x. Sin is continuous we know. Sin is what? Continuous we know. 1 also what? Continuous. 1 is what? Polynomial. 1 is what? A constant polynomial. Constant polynomial is continuous. We have seen in the example sum. So every polynomial is what ma? Continuous at any real number. Okay. So that 1 also continuous. Sin also continuous na. Then surely it will be what actually? Continuous given question. But one thing you must see very carefully. Sin 0 na, what you will be getting? 0. So 1 by 0 what? Not defined. So that here sin x which is not equal to 0 you should give. Sin x if it is equal to 0 it became not defined. So you must be very careful in this case. Understand? So you write here f of x is equal to, I am taking g of x divided by h of x. Okay, here where g of x is equal to 1 and h of x is equal to sin x. H of x is equal to what ma? Sin x or continuous at any real number. Continuous at any real number. Okay, this if you want to write you can mention this is polynomial. Okay, constant polynomial. Constant polynomial. Constant polynomial is a continuous function we have seen already. Okay, right. So constant function is continuous. Even sin x also continuous we have seen. So these things we can then you write then g of x divided by h of x which is equal to 1 by sin x is also continuous at any real number. At any real numbers except sin x is equal to 0. Except, see, any real number it will continue except 0. Sin x is equal to 0. Okay, sin x is equal to 0 now. What it mean? What it mean? When and all it will become a 0. X is equal to when it will become 0. X is equal to what? X is equal to sin inverse of 0. Then x is equal to n pi. At x is equal to n pi, at x is equal to n pi, it is not possible. Other than that, it will be possible. It will be continuous. We can say. Okay, that x is very important. Huh? Right, like that cosecant. Cosecant is over. Then secant function. Draw the line. Then we'll go to secant. Secant. Then you take let secant. Same manner f of x is equal to secant function. Secant function now how you can write 1 by cos x. 1 by what my dear? Cos x. That we can assume. So that that we can assume f of x is equal to what is that? G of x divided by h of x where g of x is equal to 1 and h of x is equal to cos x or continuous function or continuous at any real number. So here 1 is what, Raja? Very good. 1 is what? A constant function. 1 is what? A constant function or constant polynomial you can say. So constant function is also continuous, that we have seen. So that then what we can say? Then g of x divided by h of x which is equal to 1 divided by cos x is also continuous at any real number, except what pa here you can write cos x must be not equal to 0. Okay, so except cos x is equal to 0, except when you write don't put not equal, then what I'm getting, x is equal to cos inverse of 0. Where you will be getting cos inverse 0 Raja? 2n plus 1 into pi by 2. Am I right? So that 2n plus 1 into pi by 2. It means all the pi by 1 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. All the place cos will be 0. Understand? That is what 2n plus 1 into pi by 2 I am writing. This is for a secant. Like that, cot means cotangent. Cot will be going. So cot, let f of x is equal to cot x, cotangent only I am writing as a cot. So cot means what Maharaja? Cos x divided by sin x. This is also we can assume that g of x divided by h of x, where g of x is equal to cos x and h of x which is equal to sin x are continuous at any real number, any real number except what ma? Except denominator what? That is, here you should write sin x not equal to 0. Okay, except sin x is equal to 0. Understand? Except okay, oh sorry, this is separately na? Separately is continuous. Then after that you have to write. Then g of x divided by h of x. G of x what? Cos x. H of x what? Sin x. Is also continuous. Is also continuous at any real number. At any real number. Here only you should write except. Okay. Except sin x is equal to 0. X is equal to sin inverse of 0. Then x is equal to n pi. So x equal to n pi, which is not continuous. Other than that, it will be continuous. Question number 22. Raja. Right. Next. After 22, what we have? Discuss the. Oh, sorry. This is not. Okay. Continuation we will see in the next class, Raja. Continuation we will see in the next class. I hope based on trigonometric functions, you will understand how it will be continuous, not continuous. Okay. See, trigonometric functions means maximum 6, even tan also missing. Tan also can I give then? Tan is missing. Tan, maybe they have given in the example sum. Can you see what is the example number? Tan is continuous. I hope they have given. Tan also I will give. So let f of x is equal to tan. Tan means what you will be doing, Daraja? Example? Okay, example 18 it seems. So sin x divided by cos x. If you have prepared that sin and cos is continuous na, all other 4 function you should learn. Okay. So here cos x which is not equal to 0 you have to say. That means this will assume that f of x is equal to g of x divided by h of x, where g of x is sin x and h of x is a cos x are continuous at any real number. Any real number. Then g of x divided by h of x is equal. G of x is what? Sin x. H of x is what? Cos x. Is also continuous at any real number. At any real number except what is the denominator? Cos. What is the denominator? Cos. The cos must be not equal to 0. That is what. So except cos x equal to 0 this will be continuous. So that x is equal to what you will be getting? Cos inverse 0. Then x is equal to 2n plus 1 into pi by 2. Okay, 2n plus 1 into pi by 2, except that tan also will be continuous. Children, so tan x we have seen continuous, cot x also we have seen. Okay, cot also we have seen, and cosecant and secant we have seen. So totally 4 function. Other 2 function proper steps I gave. Cos x proper steps I gave. Even sine also proper steps I gave. With the help of theorem 1. Theorem 1 in the sense what? Theorem 1 in the sense what? This is theorem number 1. With the help of theorem number 1, the addition, subtraction, multiplication, tan, cosecant, secant, cot, everything I have explained. I hope you understand this. Thank you, children. We'll see in the next video. Take care. Bye.